Now, in the last video, we set up our applications project to use Go modules and also to initialize it with Git. Now, in this video, we're going to be looking at setting up our application's entry point so that we can actually run our application and then build on top of this in the future videos to do things like, network programming or possibly processing images. Cool. So let's create a new directory, and I'm going to call this CMD. And then within this, I'm going to create a CLI directory. Now, within this directory, I'm going to create the main.go file for our CLI. Main.go, not mail.go. Cool. I'm going to start off with the package main, and I'm going to do the following. So import fmt, func main, fmt println, our application entry point, like so. Now, why are we doing this within a cmd/CLI directory? Well, the reason for this is we might want to extend our application in the future to have multiple entry points. So the best practice for this is to have our CLI entry point within the cmd/CLI directory. In the future, if we want to expose the functionality of our application as a server, say as a REST API, we could do a new folder within here. We could call it server, and we could create another main.go within here, main.go. And we could have a similar entry point that would start our application as a server in the future. For now, let's delete this as we don't need this. But hopefully that gives you some insight as to why we're structuring it in such a manner. Now, I should note that this is personal preference. If you know for certain that your application isn't going to extend past a CLI, then you might want to just keep the main.go file within the root directory. Again, personal preference, it's totally up to you, but for the purposes of this application, I'm going to be structuring it in this way. Cool. So the next thing we want to do is to look at how we can build and run our application. So in order for us to run this application, we can do go run cmd/CLI/main.go. That's going to print out the fairly boring our application entry point. Let's change this now, and let's do something like awesome CLI v0.01, and we'll use semantic versioning. Doesn't really make a difference, but let's have a bit of fun with this. Let's run this again, and we've got a slightly more interesting output. Okay, so we now have this command. Let's take this. Let's go into the README, and let's update the running locally instructions. Let's say if you want to run this application locally, then run the following command. Cool. Now the next thing we want to do is to look at how we can build this application. So we're going to be wanting to create a CLI, and typically you would compile a CLI as a binary executable, and then you would add that to the path of your application of your local machine, and then you'll be able to run this from anywhere. So let's take a look at how we can do that now. Now we can run the go build. We can set the output of this as, say, CLI, and then we can pass in the path that we want to compile. So cmd CLI main.go. And as you can see, if we do ls-a, it's created a CLI for us. Let's clear this and let's do /CLI. And as you can see, our compiled binary executable has been executed and it's printed out the awesome CLI version 0.0.1. So once again, we've introduced a new command, which is the go build command. So let's copy this. And again, let's go into the README and let's do bash, copy this command in, and let's say, in order to build this application as a binary executable, we can run the following command. Perfect. So one final thing I want to do is to create a git ignore. and I'm going to add the path to the CLI output that we have. Now the reason I'm doing this is I don't want to be able to add and push up a binary executable to my GitHub repo, as it just bloats out the repo and it's not necessarily the best. So I'm just doing this for a bit of housekeeping. We're then going to git add, git commit, and git push. So clear, git status, git add. Let's do the git ignore first. Git status, and let's add everything else. Git commit, and we'll say initial commit. Let's do git push origin main, and our code should now be live on our project branch. Perfect. So that's all we're going to cover in this video. Just to recap, in this video, we've created the application entry point, which for now is just a fairly lightweight main function within the cmd CLI main.go file. We've also looked at how we can build and run our application, and we've done some light housekeeping by adding the git ignore file to our project. Now, up until this point, we've done all of our Go programming within the package main, which is denoted at the top of this file. Now, this has been purely for educational purposes, and due to the fact that for each of the topics that we've covered, none of the topics warranted splitting out anything into multiple packages. However, now we've entered the major leagues, and we need to start looking at how we can deconstruct our applications into a series of modular packages that are easy to test, self-contained, and loosely coupled. Now, before we dive into the code, let's first consider what packages are. Now, when I think of packages, I like to think of self-contained logical groups of code. For instance, in this tutorial, we're going to be implementing some network-based commands that will perform network actions such as pinging an IP address or scanning at a given port. Depending on the size or complexity of each of these tasks, I would tend to group them all under a network package, which would contain only the code needed to perform any network-specific actions. Now, this is a key point that I should highlight. When crafting your software, try and ensure that you write it in such a way that each function is only responsible for one given task. For example, when we implement the ability to ping an IP address, the function that we'll create should only send a network ping to this IP address and return the response. Now, good examples of this exist within the Go standard library itself, so it's worthwhile taking a quick look at the packages there to see this in action, and one good example of this is the encoding/JSON package. Cool, so let's create a new package, and to do that I'm going to create a new directory. I'm going to call it internal and /network. Now note, I'm putting this within an internal directory just because that's personal preference and that's like how I like to build my Go applications. However, you could move this network directory up one to the root level and it would still work as expected. Cool. So now within this network directory, I'm going to create a ping.go file, which is going to be the first file within our network package. So at the top, let's do package network and let's save that. Now within this file, we're going to want to create a ping function. Now this is going to take in an IP, and for now let's do fmt printline that IP, so we don't have to return any response, and saving that's going to import the fmt package. Now let's add a comment at the top, so this is going to take in an IP and ping that IP before returning a response. Okay, so this is what it will do. Now before we go into the actual implementation, I want to highlight a few things. So the first is the capitalization of this ping function that we have here. Now this is important within Go. When we capitalize a function, what we're effectively saying is we want this to be exportable, and this effectively means that within other packages that import this network package, we can then call this ping function. If we left this as lowercase, it would be a private method or function, and it would only be accessible to this network package. Cool. So with this stub function now defined, let's take a look at how we can import this package into our entry point and then call this exported ping function. So let's open up the main.go file, and at the top, what I'm going to do is I'm going to add a new import, and it's going to be github.com/tutorial edge. And if you've forgotten, you can check in here, beginner's guide project. We can steal this, tutorial edge/beginner's guide project. And then we have to give it the path to this package. So it's in the internal directory, internal/network. And then within the main function, we can then do network.ping. And you can see it within my editor itself that it's offering this as a suggestion. Now, we don't yet have a way to pass in IP addresses, so let's just say hello. With this in place, let's go into the terminal and let's try and run our application. So what we expect to happen is that this entry point is going to print out this awesome CLI v001. It's then going to reach out to the network package and call the exported ping function with hello. And if you'll remember, we've just kept this as an fmt.println within the body of this ping function, so it should just print out hello. Let's see this in action now. So let's do go run cmd CLI main.go. And as you can see, it's worked exactly as we expected it to. Go. So let's change this to something that looks like a network or an IP address. So let's do 127.0.0.1 and rerun it. And as you can see, it just prints out that IP address. Cool. So within this video, I'm not actually going to go into the implementation details as to how you can ping an IP address. Instead, I'm going to leave a link to a tutorial that I've written previously in the text version below this video. So take a look at that, and I'm going to leave that as an exercise for yourselves to take this forward. However, in this video, we have been successful in creating our very first package, which we've called network. We've then looked at how we can do exported functions or create exported functions. And then we've looked at how we can import these within our different files within our project, such as the main.go file. And we've then looked at how we can then call these packages and the exported functions within them.